And welcome to the 40th Annual Spinach Conference. This is session Lightning 1.2, Lightning Round 1.2 maybe, entitled Specimen Spotlight. And I am your moderator, Paul Mayer, and my co-moderator is Jessica Utrip. If needed, no, we don't, okay. This year's meeting was made possible in part by the generosity of our sponsors. So this is serious because the sponsors really save us a lot of money and make our registration fees and stuff a lot lower. So if you can, go up to the room and talk with them. We have the title sponsor this year is Delta Design or Brenziel. Our diamond sponsor is Picture A, and the platinum one is Max Communications. So if you have issues or some questions, or just tell them what you do and they might be able to come up with a solution or something, but please talk to our sponsors if you haven't. Just make them feel welcome or tell them thank you. We are grateful to them and Icon Event Group for today's tech support. And our tech person has loaded this in and has showed me how to do it. And hopefully I will do it correctly. This session will be recorded for later viewing, although not today. It'll take a few days for this to get up, if not longer. And posted to the Spnhc YouTube channel. However, we have previous specimen spotlights from 2019 on up. So if you want to look at older specimen spotlights, they're all on the Spnhc YouTube channel, so you can do that. Thank you for joining us, and thank you to all the speakers in this session. Yes, thank you, speakers. We have 12 talks this session with no breaks, so each presenter will talk for 5 minutes. There will be no time for questions, so that includes the folks in the cyberspace and here. But you might be able to ask questions at the end of the session, probably not because we're going to go right to lunch. But if you find the speaker or email them, they might reply to you. If you are the next speaker, please come up and wait so that you can transition very quickly. I will switch the slideshows over, and that'll save time. I'm not going to introduce the speakers. You please introduce yourselves just to save time and let you have the most amount of time that we can. Quick transition. Speakers, please introduce you. Okay, we did that in order to save time. I will, or Jessica will wave or stand or catch your attention when you have 1 minute left, so try to acknowledge her so she doesn't have to wave the whole time. And then once you're done, I will stand up and walk towards you in a menacing fashion until you leave. All right, virtual online, no questions. Audience, no questions. Please use the online chat judiciously, as any inappropriate use of the chat may result in you being removed from the session, so keep it classy, Spinach. If you would like to continue the conversation online, continue using the chat function, Oxford Abstracts. That seems makes sense. Please enjoy the session, and thank you very much. And we got about 2.5 minutes before we start. Any questions, concerns, irate comments to start off?
Do you want to do an announcement real quick?
Oh, do we have breaking news?
Yeah.
Excellent.
And he said to do it at the end, but
Oh, well, we'll do it both. All right, we have a breaking news announcement. T-shirts need to be picked up during lunch. Both existing orders and those who reserve shirts on site. Well, if you order the shirt on site, pick it up at lunch.
yeah, that's not even a word.
Yeah, otherwise they'll be gone. So make sure you get them at lunch. I don't know what will happen otherwise. Probably nothing good. And I'll leave this up here so I remember to do it when we leave. All right. So. All right, so yesterday we left off with Pico the polar bear and the one-armed lion trainer who got mauled to death. And we'll start off with grizzly bears. And,
Let me know.
what? All right, well, you got 1 minute, so if you want to come up here and.
I've got one more.
Well, I got 10:59. I don't know how accurate that is, but.
Pretty accurate. All right.
Yep, you can give yourself a longer 30 seconds.
Okay, great. Wonderful. Okay, well, welcome everybody. Thanks for coming. My name is Katrina Derrig. I'm the curator of the Philip L. Wright Zoological Museum at the University of Montana. That's kind of a mouthful, so I'm just going to refer to it as the UMZM throughout. And so I'm going to be sharing with you this really cool series of specimens. It's not just one specimen, but a series of specimens that we've got in our collection from Yellowstone National Park. And this collection is particularly special to us because we are the Montana Grizzlies at Go Grizz. So I first want to give a little bit of background on Yellowstone. Who's been to Yellowstone? Bunch of people. Yeah, we're pretty familiar with Yellowstone, but it was the first national park in the world, not just the country, in the world, established in 1872, and it is about 9,000 square kilometers, about the size of Puerto Rico, or double the size of Rhode Island if you've been to either of those places. Very famous for its geothermal features, like these colorful pools, a lot of thermophilic bacteria, as well as the geysers like Old Faithful here. And of course, it's famous for megafauna, so bison, wolves, and grizzly bears. So there are about 700 grizzly bears in the greater Yellowstone ecosystem in the whole area, and 150 within the park boundaries. And this park is one of the most visited national parks, about 4 million visitors annually. And I'm sure we've seen lots of terrible videos of people interacting with the wildlife in inappropriate ways. But this population of grizzlies in Yellowstone had not really been studied prior to the 1950s. And so the notable naturalists, Frank and John Craighead, they were twin brothers. They started studying grizzlies in the park in 1959, and they were radio collaring these grizzlies. And some sources credit them with the invention of radio tracking technology for wildlife, and this is something that's used standard in wildlife management now. And they also pioneered a lot of tranquilization techniques that are used today. So yeah, really just pioneers in their field. And they studied all kinds of aspects of grizzly bears, tracked them throughout their life, had many publications. And what's really nice about radio collars is that it will alert the researcher to when the animal stops moving and is presumed to be dead. So then you can go and collect the carcass. And so that's what they did. And so we ended up with some of these grizzly bears. So I think they had radio collared well over 600 bears in their time. And so we have 61 specimens at the UMZM. They're all searchable on Arctos. Most of them are skulls. We have some postcranial material and a bunch of really gorgeous pelts in our old-fashioned pelt cooler. And the first collared bear that died was collected in 1960. And so that's not the earliest bear that we have, but it's the one that says, John Frank Craighead #1 written on the skull. So that's the first one is what I call it. And so you might be wondering what happened to the other 500 or so grizzlies that they collared and tracked. And the answer is I do not know. I presume the park itself has some of these specimens, but if anyone else has some of these specimens in their collections, I'd be curious to know about it. It's kind of a mystery, and maybe they never end up in collections. Hard to say. But in any case, this story just serves as another example of how collections, natural history collections, hold a lot of important history, human history as well. Because this family, the Craigheads, they're well known in Wyoming. They still live there today. I've been meaning to reach out to them and say, hey, you want to come see the specimens? And I guess I don't have time for questions, but thank you.
All right. Oops.
You're so right. So good morning, everyone. My name is Logan Roberts, and I just recently finished my internship with vertebrate zoology at the Natural History Museum of Utah. And today I've got sort of a 2-for-1 specimen talk for you. So when I first started my position, my boss, Katrina Derrig here, gave me a huge bag of rodent guts to go through. to search for gastrointestinal parasites. And one day while I was going through one of these gastrointestinal tracts, going through the usual slurry of peanut butter bait and insect parts, I found this really weird, tiny red triangle, and I wasn't sure what I was looking at, so I put it under the microscope, and my other mentor, Dr. Eric Rickert, came to take a look at it and said, "That's a shrew tooth." So what we saw under the microscope was this. These are close-up composite images of the two fragments we found in the gastrointestinal tract of this grasshopper mouse. The one on your left is pretty obviously a incisor. It's an upper incisor. We know it's a shrew tooth both because of the size, if you notice the scale bar, and because of the deep red coloring. The other fragment we originally thought was another tooth, but after looking at it more closely and comparing it to other teeth, we don't think so. I'm not sure what it is, it's bone, but not sure on that. And we are still not quite sure what species of shrew this comes from. We're working on it, but have some thoughts. Not quite sure yet. So why is this interesting? Why is this important? First of all, as I said, this came from a species of mouse called the grasshopper mouse, northern grasshopper mouse. These mice are known for being aggressively carnivorous. They go after venomous bugs like the scorpion in this picture. They're known for eating other mice, even members of their own species. But we looked through the literature and we actually did not find any mention of them eating shrews before. So this finding of the shrew teeth represents a novel predatory interaction between these species. The other reason this is interesting is that this grasshopper mouse specimen came from our survey of Goblin Valley State Park, which is located around this orange star in southeastern Utah. We conducted a novel survey of Goblin Valley from 2022 to 2024. And following the finding of this tooth, we did make some concentrated efforts to collect shrews in the park, but we actually did not collect any other shrews from the park. So these teeth also represent the only indication, but also definitive evidence that there are shrews in Goblin Valley. So the ultimate point is that holistic vouchering of specimens is still a powerful tool for understanding interactions between species. Active collecting and holistic vouchering, the extended specimen concept that we've heard so much about is still allowing us to discover novel ecological interactions. All right, thank you.
Moving quicker than I would have anticipated. Uh-oh. This is not the right time.
Oh, okay. You're looking for Marcus unsold, 2.5 blocks. You already shot all your bullet on this one. Did you hear me, Paul?
Yes, I'm looking for the ox. Marcus, are you here? No? What? Marcus? That might explain why I can't find the talk. All right.
Recorded one. Next one's a recorded.
Right.
But if we want to stay on time, does anybody have a story they want to share that they don't have slides for? Oh, yes. Yeah, come on up. Really? Yeah, why not? I'm the timekeeper. I'm keeping time. Sure.
One last call for Marcus. He's
You got 6 minutes. At the mic. As long as you keep it time. Okay. speak into the mic. Yeah, introduce yourself, speak into the mic. Sit down, Paul. We got this. We didn't find Marcus. We had a chance. You guys gotta be on it.
Well, hi everybody. I'm not sure if you've seen me yesterday, but I give a talk about fish. So I have more fish to tell you about. So I'm from Western New York, I'm from Buffalo, and we were working on restoring our fish collection, and we found some many interesting things. One of them being fish from the West Valley Demonstration Project, which is a nuclear reclamation site. So we panicked, obviously, because nuclear waste and radiation. We got a Geiger counter and found out that there was no radiation. But it's like, whew. But it's super cool because they were doing these environmental surveys to see if the reclamation was successful. And it was. So that's cool. The end. That's one. The second one is, have anybody been to Niagara Falls? Yeah? Has anybody ever known that Niagara Falls was once turned off? Yeah? So Niagara Falls was dammed up, and maintenance was taking place in 1969, and they they restored a bunch of the fallen concrete, because the way that Niagara Falls works is there's a hard limestone that's underneath some other more softer rock. I'm not a geologist, but it erodes over time. So they were restoring this, and they turned the falls off. And have anybody ever heard of a freshwater drum before? Like those fish? They're slow moving deep water fish. So these fish got stuck in the pools when they dammed it up, and then they were collected, and we just found them in the museum. So we have fish from when they turned the falls off. So it's pretty cool. And that's it. I have pictures if anybody wants to see pictures.
Oh, thanks. World's my favorite. All right, well, you've got 4 minutes to pull
Yeah.
up the remote dock.
Oh, I got help. I didn't trust myself.
Anybody have a 4-minute
You-
story?
We don't have to start it yet. We still have.
Well, hold on. You can each have 2 minutes.
Whenever you're ready, hit the space bar.
Just hit the space bar.
Yep,
Okay.
it should start.
All right.
I'm the curator. Go
Go to
ahead.
the mic.
Oh, sorry.
2 minutes.
Hi, I'm Marshall. I'm from Virginia Museum of Natural History, collections, vertebrate stuff. My cool story is that we had a predator, I believe it was a fox, that had a fish in its stomach contents that had a tongue louse in the fish. So we had our own turducken.
I'm Bob Tim. I was curator of mammals here for 35 years. And you've been to the panorama of the museum, perhaps, and you see those spectacular bison specimens. And so I'm interested in the old specimens in taxidermy. And the taxidermist who put those up isn't the guy who went out into the Montana to shot them. That was a neat guy I can tell you more about. Anyway, so they went to Montana, shot these bison, brought them back, Dyke prepared them, and we have great pictures of Dyke preparing these specimens. And I'm looking at these neat pictures, and on the femur of one of those, there's a third trochanter on the femur. And the bone nerds here are saying, huh? Anyway, big third trochanter, that means it's a horse femur. And so when you're looking at these old taxidermy mounts that guys shot, and brought back the skull, and maybe they have the terminal leg bones there, they used other bones from other mammals to make their mounts. So when we are looking at our specimens, we got to worry about what's all inside there, because it may not be all that one animal.
Composite.
It's a composite.
Well, that worked out better than I thought it would. We've got about 30 seconds, and then we'll start up our next speaker is Sarah Rushing, and this is a pre-recorded talk. So I assume Sarah's in Cyberland. Soraya? Oh,
There's a
oh, it is. There's an A there, sorry. Soraya Rushing. Where is she from?
Lindsay Wildlife, California.
Oh, it's up there. Look at that.
California.
It's not even on my screen
It's
here.
not on my paper either.
Okay, good. But no, I mean, the video isn't on my,
Lindsay Wildlife Experience in California.
thank you.
Thanks, Mom.
All right.
Hello everyone, my name is Soraya Rushing and I am the Natural History Collections Specialist at Lindsay Wildlife Experience located in Walnut Creek, California. Looking at this desert tortoise specimen, we can see healed wounds, but the record only told us that it was from a healed injury and surgery. Now, it is my pleasure to tell you the story of Moji, a beloved pet living to be estimated over 100 years old. He might not be famous or known across the world, but the single taxidermy story is as unique as our facility, and his story was almost lost to us. The Lindsay Wildlife Experience is an educational museum, zoological institution, and a wildlife rehabilitation center. In December of 2024, we accidentally found paper records about our specimens while looking for permit documents. A quick peek through told us we had found information about our specimens no one knew existed. This is how we refound Moji's story. The first page of the paperwork was the original request to us inquiring about our interest in a concept. The family would taxidermy their beloved pet and fund an educational display to inspire people to help with conservation efforts for California's state reptile, the desert tortoise. This immediately caught our attention as it was unusual and became a top priority, being one of the first records we would process. While reading the additional correspondence at the time of the donation, we had received 2 3-page long typed up stories, one focused on the facts and one telling the story of Moji. The family also provided 2 photos of Moji while he was still alive. He hatched sometime around 1900 according to veterinary estimates and was found in the Mojave Desert in 1920 by a family heading home from vacation with 2 large cracks in his shell, a broken beak, and a broken jaw. He had most likely been hit by a truck. At the time, this was an incredibly small chance, unlike the risk that desert tortoises face today being crushed by off-roading vehicles. Not knowing what to do, they grabbed the animal and brought it home with them to Albany, California. They took the tortoise to their local vet who only treated cats, dogs, and farm animals. This was before the country's first wildlife hospital was established right here at the Lindsay Wildlife Experience in 1970. Moji survived with one of the cracks still visible on his shell and had permanent damage to his jaw and vision. The original family moved to Seattle, Washington, and Moji found his new home with the 5-year-old next-door neighbor, Ernie. Moji would stay with Ernie and his partner Keith until Ernie passed away. Keith was the cousin of the final family to take in Moji. Keith had to travel for work and asked the Larson family to watch Moji, who asked to watch him a little longer and then became a permanent part of their family. By this time, he was around 90 years old and had developed a large bladder stone and required surgery. A portion of the shell was cut and fiberglass was used to help repair the shell, another element still visible on the specimen today. Incredibly, his story is tied to our facility even before he became a part of the collection. Reading through the stories, it tells us that the Larson family would often bring Moji to the park right outside our facility to explore and play with the children in the park. The family had hoped to create a personal connection for children through Moji's story by preserving him and his story. And while it was almost lost, we found it and are able to continue telling his story and inspiring the next generation, connecting them to wildlife.
Oh, okay.
You should be getting up.
So which one is yours? Is that? Oh. There we go. Perfect.
Good morning, everybody. My name is Laura Abrazinskis, and I'm the collections manager of vertebrate collections at the Michigan State University Museum. Our museum was established in 1857, and we have vertebrate specimens that number over 117,000. These are used for research and teaching, and they are worldwide in scope. And provide a record of biodiversity that ranges from 1844 to the present. One of our noteworthy specimens is a taxidermy-mounted Arctic grayling, Phymalis arcticus, that was collected from the Otter River in the Upper Peninsula of Michigan, and described as a beautiful fish with shimmery markings and a sail-like dorsal fin. Arctic grayling were once abundant in multiple river systems in the lower peninsula of Michigan and also in the Otter River, which is in the upper peninsula of Michigan. The species was recognized as an important Michigan game fish in 1865, but by the early 1900s, it was gone from the lower peninsula, and it was a victim of logging, the introduction of non-native species, and also habitat destruction. The museum's Arctic grayling was collected in 1925 by Fred A. Westerman, and it was bequeathed to the museum in 1976. And I'm going to read some of his words about collecting it. So, quote, the specimen was taken during mid-September 1925 from the Otter River. Myself and several associates from the Division of Fisheries of the state spent several days on this stream to take 130 grayling, along with suckers and rainbow trout with seines. These grayling were mostly released in the Cedar River in Gladwin County, and that's in the lower peninsula. And perhaps 20 went to the state fish hatchery in a futile endeavor to reestablish these fish in waters of the lower peninsula of Michigan. In 10 years, they completely disappeared from the Otter River. This mounted specimen was one of the largest taken, unquote. So, and this is kind of a close-up of it. It's really like in a wooden frame. And there is a line and a tied fly on, you might be able to see that in the image. So underway at present, there is a collaborative effort to reintroduce this species to Michigan waters. And so hopefully this will be successful, and one day these beautiful fish will swim again in Michigan's waters. And if anybody knows anything about a McGinty fly or a gray hackled red fore and aft, those are in the literature as being associated with fly fishing for this species. Thank you very much.
Sir?
Well, thank you very much, guys, for being here today. Thank you very much for your interest in what I hope won't be a really, really short talk. Although I have, given several talks over the years, I still get super nervous and start like talking really, really fast. So I hope it's not a really short talk. As I mentioned, my name is Enrique, and I work at the Illinois Natural History Survey located at the University of Urbana-Champaign. At INHS, I help to manage and curate about 1.4 million specimens preserved in 5 different collections. For those who are not familiar with INHS, it is one of the, let me tell you that it's one of the oldest surveys in the nation. And if you're interested, of course, I can tell you more about what I do and what I don't do, and of course the NHS. Today I will hopefully give a talk that won't be too short, and I'll be talking about the specimens collected by by Stephen Forbes. Probably at this point, many of you are like, well, who is Stephen Forbes? Let me tell you, he was a major figure of the Midwestern United States science. He was born in 1844 in Illinois. His interest in natural science was determined by his family agricultural background, but all the years he spent outdoors, his service in the army, and by his short incursion into medical school. Over the years, he became a professor, a scientist, a museum curator, and later on his career, an administrator. In 1877, Forbes established the Illinois State Laboratory of Natural History, today known as the Illinois Natural History Survey, or INHS. Forbes published about, I think, 500 articles on natural history with insects, fishes, animal interactions, and the role of these specimens in their ecosystems. Possibly his most famous publication is The Lake of Microcosms, published in 1925. It is a classic publication that lays out many of the principles of modern ecology. The concepts and ideas portrayed in this publication were so influential at the time that the National Academy of Science recognized him as the founder of science in the the founder of science of ecology in the United States. So Forbes and colleagues were really avid collectors. Over 35 years, they collected, they visited 93 counties out of the 102 counties in Illinois. They sampled about 450 localities. They collected about 200,000 specimens representing 150 species. Their effort culminated in the publication of the Fishes of Illinois in 1908, which set the foundation for further publications, including the Fishes of Illinois 2.0, I guess, published in 1972, and the Atlas of Fishes of Illinois Fishes, published in 2022. Additionally, his publications was one of the first ones that ever used or printed these distributional maps with the dot maps, which are very commonly used today. Unfortunately, like many collections, many of his specimens were lost. At some point, they were deemed unimportant, and today INHS preserves only, I think, around 3,000 specimens collected by by Forbes and colleagues. These specimens represent 27 families, 147 species, 13 type specimens, and we still have some very unique records of extinct, extirpated, imperiled species, like, for example, the hair-lip sucker on the top right, I think, extinct, once considered abundant, but the last seen in 1893, and has disappeared from 8 US states. The scarlet shiner, now an extirpated species in Illinois. The specimens that I'm showing here on the bottom right, I believe, those are the only 6 specimens ever collected in the state. They are all gone by this time. And I think, lastly, the pallid sturgeon described by Forbes on the bottom left in 1905, once considered also a very abundant species, now gone through, 1 minute, perfect. Thank you very much. So, in conclusion or summary, I think that all these Forbes specimens show his passion for the observation, description, and interaction of organisms in natural history in international habitats. They are a physical record of his academic and scientific career, but most importantly, the specimens are tangible records of Illinois' biological memory. If you're interested or want to know more about the other biological collections, we have 11 biological collections. Please feel free to scan the QR code or shoot me an email, and I will be more than happy to answer any of your questions.
Yep. So
So good morning. My name is Catherine Jastrzemski. I'm a science advisor and manager at the Canadian Forest Service, and I'm presenting today on behalf of Christian Hébert, who's a research scientist and the curator of the René Martineau Insectarium at the Laurentian Forestry Centre within the Canadian Forest Service. So within the Canadian Forest Service, we have several collections, including over 1 million specimens, including those of the René Martineau Insectarium. So today I'll talk about Neospondylis uniformis that was collected on Anticosti Island in Quebec. So the Neospondylis uniformis is a species of long-horned beetle in the family of the Cerambicidae. And the special specimens were collected on Anticosti Island that you see on the map here on the right. Anticosti Island contains one of the largest areas of boreal forest south of the 50th parallel with little or no human exploitation. It's a unique ecological environment. Throughout the years, several entomological surveys were conducted on Anticosti Island dating back to 1872. Specimens that we're highlighting today were collected in 1993. So why does this or these specimens matter? Neospondylis uniformis is not a rare species. In fact, it's a common species in Western North America. So why are we talking about this species today? It's actually uncommon in Eastern Canada and has a very local distribution. 333 specimens were caught on Anticosti in 1993 and 2007, which is far more than in any other places in Quebec. So only 7 specimens were caught elsewhere in Quebec between 1993 and 2015, and only 14 specimens were found in the 45 most important insect collections within the province, the latest specimen dating back to 1964. So therefore, Anticosti Island is a hotspot for Neospondylis uniformis. So at least 90% of the captures occurred in old-growth balsam fir stands. And so whether Anticosti Island is a suitable habitat for this species because of the abundance of the old-growth forest, the presence of large white spruce, particular climatic conditions, or any other parameter is still unknown. So further research needs to be done on that front. And furthermore, this research allowed to document biological diversity decline actually on Anticosti Island, which include the surveys on these specimens. These specimens also matter because having several specimens within the insect collection at the Laurentian Forestry Centre allowed to conduct additional research on the sexual dimorphism, which refers to differences between sexes of same species. So usually for Calyptera, we can use the antennas to differentiate between sexes, but this criterion wasn't applicable for this species. So therefore, genitalia of a subset of specimens were dissected and confirmed that the mandible shape was actually a good criterion to determine the particular sex. So we have the female which have robust mandibles and a sharp cutting inner edge, which you see on the left, with males that have a thinner mandibles and well-rounded inner edge. So unveiling sexual dimorphism allows to determine the sex more easily and avoids the tedious task of having to dissect genitalia to have that information. More importantly, research allowed to better understand Epiformis' biology, which is limited at this point in time. So if you have further questions on this talk, feel free to contact Christian Hébert. His email is here. Feel free to browse the René Martineau Insectarium page, or if you have broader questions on collections within the Canadian Forest Service, we have a generic email address, or just come and see me or someone from my team. Thank you.
Is this yours? We multiple guests.
Yep.
Oh, good.
Hello. Good morning. My name's Christina Gogler. I'm the Anthropology Collection Manager at the Carnegie Museum of Natural History in Pittsburgh. Today I wanted to share with you a little bit about one of the most recent additions to the anthropology collection. It is an object in artwork that you can probably see is kind of hard to photograph because it's clear. I'll point out what it is. So it's called The Messenger. So The Messengers are 3 participatory artworks that were created by artist and science educator Asia Ward that were made for one of our exhibitions that just finished up this past January, titled We Are Nature, A New Natural History, that was developed by curator of Anthropocene Studies, Dr. Nicole Heller. So the parameters were to pick one object, but technically the succession is 3. There are 3 sculptures that were made for this exhibition, all of the micro animal known for being able to survive in extreme conditions, the tardigrade. You can see 2 of the 3 sculptures over there. They're quite large. They're a few feet wide and a few feet tall. They're extremely adorable. Their faces are really cute and their legs are really cute. Tardigrades are cute in general. And also in the exhibition, in the vitrine, the way the light reflected on them, they were really beautiful and visitors really enjoyed them. They are made of recycled thermoplastic, which is a material that can be heated and reshaped over and over again. It's a little difficult to recycle, but it's worth the effort to help lower the impact of plastic production, obviously. So as the name Messenger implies, these are also time capsules, and they are meant to be opened at key dates corresponding to what are believed to be important milestones for environmental change. So 2035, 2027, 2035, and then 2095. And they'll be opened as part of museum public programming. So during the exhibition, visitors were asked to answer questions on paper and center their responses, thinking about our hopes and fears for the future of life on Earth. And then these messages were placed in the tardigrades to be opened at future dates. There's sort of an artsy shot of the messages inside of the up there. So one of the things that Nicole highlighted as part of her curatorial concept that really resonated with me was that despite the fears that we're all grappling with about climate change and environmental change, to sort of paraphrase her, that these offer a promise of ongoing dialogue with our community while at the same time transmitting optimism. So in the sense, the museum is still going to be here, there's still going to be a future, and we'll be here together. So these sculptures are precious, but I wanted to talk about them more about what they represent than what they are physically. So a concept that's been a motivating force for me in anthropology has been this idea that we should have a living collection. And what I mean is that cultural collections shouldn't be disconnected from the other scientific sections, and also that a living collection should help highlight the fact that humans are intrinsically a part of the natural world, that we shape it and that it shapes us. And that also a living collection is one that is informed by and co-owned by our local and descendant communities, and that should push the boundaries of what we think about culture studies within natural history spaces. And I also think it's really important that anthropology collections aren't relegated to the past, that we should incorporate contemporary works that showcase changing material culture like thermoplastic. And I think one of the first steps to letting this idea inform our actual practices is through collaboration and also participatory exhibitions like this one. Thank you.
Hi, I'm Maureen White from the Division of Anthropology at the Yale Peabody Museum, and I've been wanting to do a specimen spotlight since Paul did his Tully Monster talk. But this is what I came up with. I know it doesn't look that exciting, but if you're an archaeologist, you probably think it's exciting. But this is actually mortar from an archaeological feature. It was described as pink cement-lined basin from the Armenia East. I just put up a little map there, site. in Egypt. This was part of the UNESCO salvage excavations in Nubia. This was during the Aswan Dam project, so these were going to be underwater. William Kelly Simpson was the director. This was a Yale Penn expedition. And there's been debate over the years about what this actually is. So this is a feature, right? You can't take the whole thing with you. So the fact that they actually took the sample is kind of amazing. But what happened was there was a student who was in our collections at the Peabody class that we offer every year. Our director has this class, and these are first-year freshmen. So they're finding projects to do, and this student, Ria Sinji, had looked at some grape specimens in the herbarium and was like, let's try and find some kind of specimen in the collections that we can test. And she teamed up with our staff scientist, which is a new position in our Yale Ancient Pharmacology program. And he does residue analysis, so he's really excited about this because Raina found this specimen from this basin, and there's been debate about what is it. Starting in 1868, they were thinking this was a gold washing station, and Simpson kind of kept up that story in the London Times after this, but his excavator said, oh, wine press, ? So we actually cataloged it as wine press ? So the student was able to find it, and going through all of the field documentation, she was able to find more evidence. But there was even a publication in 2019 saying, oh, it was a bath or a cistern or some other ritual water site, because there are 12 known, but none of them are now accessible, and there are some in Sudan, which also is not accessible. So Andrew's really excited about taking this on further, but when he did actually do the, wrong way. He came up with a signature for grapes. So this was a definitive kind of these decades, almost a century long debate about what it is. He was able to find the signature, but he also is starting a database, a phytochemical database that he can build onto. There's also other additives that he was able to find, but for the student project, this was about as far as they took it. So the fact that the mortar was collected during a salvage excavation and was cataloged, it wasn't cataloged till the 1990s. So we're lucky we didn't throw it out, but it did have some, documentation. So that's impressive. And the use of modern chemical techniques, photographic archival evidence helped to solve decades of debate of a site that is now underwater. And also, I haven't found anything where they found gold in any of these. But you can see in the tank, it's 3, and so the specimen was taken from like the 3rd tank, which we think is the fermentation. So lots of potential. This is a split collection, so Penn has some, Yale has some, and then some were left in Egypt. So I also want to do a plug. We do have a new job posting. A new job posting for head of anthropology collections at the Peabody. So if you know of anybody who's looking to solve some mysteries and work with me, we have a job for you. Okay.
And that posting is up on the Spinach jobs board.
Right, I got the right one. Amy?
Yes.
All right, and, well,
Are we early? I can wait.
we got you can stretch it a little bit.
push. This one?
This one here.
Got it.
But you got a little. We oddly enough are tracking really well on time. That's unusual.
Do you think you're gonna be 5.5 minutes?
No, I have 4 minutes, 30 seconds.
Great.
Maybe a little faster.
Faster, so I was like. Yeah, I talk so fast. Well, thank you to everybody for really being on time and Paul for being an excellent moderator and getting all the slides up.
Moving along quickly, and you can probably start now again.
Sure.
All right, hello, I'm Amy Weiss. I'm the collections manager in the herbarium at the New York Botanical Garden, and I'm here to remind you that herbarium specimens have many stories to tell, and sometimes when you least expect them. So this story begins with a routine check of the type status of the herbarium specimen pictured here. Reading a paper, I was struck by the statement that while a specimen of R.C. Ching 5512 is held by the New York Botanical Garden, it was, quote, unfortunately in safe storage for the duration of the war and is not available to study, end quote. Asking around, none of my colleagues could recall anything about this storage, so I was compelled to investigate and was able to rediscover the steps taken by the New York Botanical Garden to protect their collections during World War II. While in hindsight, the continental United States is not in danger of a large-scale attack, it helps to remember the mindset of Americans at the time. So the bombing of Pearl Harbor on December 7th, 1941 was a real wake-up call for all Americans during the Second World War, including American museums. If Japan managed to bomb Hawaii, it seemed just as likely they could do the same to West Coast cities. The Eastern Seaboard seemed equally vulnerable with the successes of the German U-boat fleet in the Atlantic Ocean and the rapid German occupation of Western Europe. So shortly after the United States entered the war, the Committee on Conservation of Cultural Resources recommended that cultural institutions should plan now for dangers from enemy action, but also dangers arising from emergency activities at home, like a depletion of staff and budgets. The committee also cautioned that while evacuation is an extreme measure that may not have to be undertaken, preparations should be made if the institution was located within 150 miles of either coast. So it seemed NYBG heeded the recommendations to make a plan, and like many other natural history collections, prioritized the safekeeping of type specimens. So at the time, NYBG's type specimens were filed as part of the general collection. So herbarium staff started pulling type specimens out of the collection at the beginning of March of 1942 with an idea to box and ship them inland for storage. On March 6, 1942, Henry Gleason, the head curator at NYBG, wrote to Perry Strasbaugh, head of the Department of Botany at West Virginia University, which is in Morgantown, West Virginia, asking if they would be willing to store the garden specimens during the war. And you can see part of this letter in photo A. Do you see the A? Okay, good. Just 10 days, oh, sorry, next slide. Just 10 days later, on March 16th, Gleason accepted the offer by West Virginia University to store the herbarium specimens. Strasbaugh coordinated the storage and care with Friend Clark, who was the head of the Department of Chemistry at West Virginia University, to store the wrapped and boxed specimens in a dry, fireproof storage space in the chemistry hall without cost for the duration of the war. As to why West Virginia University was chosen, besides being inland, it seems that there was frequent communications between botanists at both institutions. So the first boxes of specimens arrived at West Virginia University by May of 1942. In addition to type specimens, the garden also sent various rare books and the papers of John Torrey and Nathaniel Britton, who were prominent New York botanists and whose specimens are the cornerstones of NYBG's herbarium. So altogether, 38 boxes of specimens and books containing over 41,000 specimens were stored in West Virginia. The director of the garden, William Robbins, wrote to Clark at the end of September 1944, saying that it was time to return the collections to New York, and Clark did so at no cost to NYBG. As thanks for the safekeeping of the irreplaceable specimens and books, NYBG commissioned a plaque to be sent to West Virginia University. Due to a shortage of bronze after the war, the plaque did not arrive until December 1948. The chemistry hall at West Virginia University, where the specimens were stored, is now called Clark Hall in honor of Friend Clark. The plaque is mounted to the side of the building, which you can see in photo C. Since I only have 5 minutes and I only have 1 minute, if you want the full story with more details, that can be found on the hand lens, which includes what steps other American herbaria took to safeguard their specimens, plus some insights into type segregation and annotation. A link to the story is in the QR code on the screen. And finally, piecing together the story would not have been possible without archives and annual reports. So the next time you're dreading writing up the work and projects done in your collection, please remember the people in the future that might be curious about those details. So thank you.
arrow key moves.
All right. Happy Friday. So, my name is Jonathan Tardy. I'm the not science director, but director of forest biology at the Laurentian Forestry Center in Quebec City. This is part of the Canadian Forest Service within Natural Resources Canada. So today I'm presenting on behalf of Joey Tanney and Nicolas Faux, both researchers at the Pacific Forestry Center. And that explains maybe why I will have to rely a little bit on my notes here because I'm not the specialist. Joey is also the curator of the Forest Pathology Herbarium that houses over 35,000 forest fungi and disease specimens, including number 561 here, a Nothophaeocryptopus gaumannii that causes Swiss needle cast. I got it. So what is Nothophaeocryptopus gaumannii? Well, let me call it Angie, okay? So Angie, it is a fungus that reproduces by forming small black fruiting bodies called pseudothecia that emerge from stomata, permanently obstructing them in the process. Once about 30 to 50% of the stomata are blocked, gas exchange is hindered, the needles yellow, and they're prematurely cast. In severe cases, trees hold only on their youngest needles, leading to major growth reductions. This disease is called Swiss needle cast. Despite its name, this fungus is native to the range of Douglas fir in western North America, not Switzerland. Typically benign, this fungus resides without causing symptoms within needles across the tree's native range, but under warmer winters and wetter springs, it shifts gears, becoming pathogenic and damaging, cutting volume growth by up to 50% in most affected areas. So this is a really good example of how climate change is reshaping forest health in Western Canada. Even until late 70s, NG was considered a negligible fungus that caused little to no disease within its endemic range. That changed in the mid-80s when Swiss needle cast emerged as a serious problem in Oregon and much more recently along coastal BC. Because it was once considered harmless, we have very few historical records from BC. At the Pacific Forestry Center's herbarium, the oldest, number 561, was collected in 1944 from Cowichan Lake on Vancouver Island. These needles were archived specifically for pseudothecia of Nothophaeocryptopus, but unlike contemporary samples from the same area, which are sometimes peppered in pseudothecia, this one tells a different story. Thanks to genomic tools, we can use specimens like 561 to reconstruct how this fungus and the disease has changed over time. Briefly, Nothophaeocryptopus consists of two major genetic lineages, which diverge approximately 140,000 years ago. Lineage 1 has two subgroups that diverge about 20,000 years ago, one high on interior Douglas fir and one C associated with coastal trees. We found that lineage 2 was more common in the past. For example, number 561 here is lineage 2, now rarely detected at Cowichan Lake. We don't yet fully understand how lineage relates to disease, but lab work shows that lineage 1C grows faster across a wider range of temperature, including under drought, suggesting greater adaptive plasticity. Do I still have more than 1 minute? I do have 1 minute. Okay. These genetic lineages are adapted to different environments, and this influences their distribution. Modeling of expected distributions allows the environmental tolerance range of lineage 1C exceeds that of lineage 2, and that lineage 1C is favored by hotter and drier summers, which we have been experiencing more and more recently in the Pacific Northwest and elsewhere. So in conclusion, specimen 561 is more than just a specimen. It's really a time capsule. It offers a rare glimpse into pre-epidemic conditions, helping us trace how fungal populations have shifted over time. By linking the past to the present, we gain critical insight into how climate change can transform fungi into significant pathogens. That being said, if you have some questions about this specific specimen or the research related to that, please don't ask me, ask Joey or Nicola. But if you have any general question about the collections at the Canadian Forest Service, you have the address, the same that was shared by Kathleen earlier. Thank you.
All right.
All right. This is our final talk.
All right. Hi, I'm Jennifer Ackerfield, and I am the director of the Charles Maurer Herbarium at Colorado State University. And we're ending today with a story about cannabis sativa. All right. Oops. Let's try that. There we go. Okay. So we've listened to a lot of story. I know that's the best looking specimen you've ever seen, right? We've listened to a lot of stories about collections, and I like to think that all collections, every single specimen is a story, but herbarium specimens are stories pressed in time. And so, when we think about the components of a story, we've got the who, the what, the when, the where, and the whys. But on a specimen, we typically have the who, what, when, where, but we're missing the why of the collection. Why was this specimen made? And so this collection here, while it doesn't look like much, actually is a really cool story. It tells us, who collected it. P.T. Howell, who was chief engineer for the Soil Conservation Service. It tells us what it is. It's cannabis sativa, otherwise known as hemp or marijuana. It tells us when it was collected in 1936 and where, in New Mexico, but we don't really know the why. And so to think about the why, oftentimes we go back to the collectors. So for this specimen, it was collected by the chief engineer for the Soil Conservation Service. So if we have to think about what was happening, especially in the Great Plains, in the 1930s. And what was happening is the Dust Bowl. So years of drought and poor agricultural practices led to massive dust storms covering the Great Plains. These are actually photos from southeastern Colorado. And these dust storms were often so massive that they actually buried entire homesteads. So the Soil Conservation Service was formed in 1935 to help farmers, kind of make better practices for farming, as well as provide alternative crops for homesteads for these areas in particular ravaged by the Dust Bowl. So we're very lucky that this specimen also had a letter attached to it with a paperclip that was kept by the curator that received the specimen. And so we look a little closer. The specimen was received, a dried marijuana plant to be used by the Soil Conservation Service, U.S. Department of Agriculture, as a specimen in the compilation of a herbarium to enable agronomists in the employ of the Soil Conservation Service to become acquainted with the marijuana plant. It's like the longest run-on sentence you've ever seen. But if we kind of piece this apart and we think about what the Soil Conservation Service was doing at the time, they were really trying to come up with alternative crops. And so I hypothesize that one of those alternative crops that they were thinking about for these areas was hemp, which is fast growing, stabilizes sand dunes, and was a major source of fiber. So great. Right? Now we have this specimen in the herbarium so that other people know what the hemp plant is when the Soil Conservation Service begins to grow it. What happened there? Sorry. The Marijuana Tax Act of 1937 basically put a halt to all of this by enacting a really high tax on the sale and growing of marijuana, and it became unfeasible for people to grow hemp as a crop. So, wah. But we have this letter still that provides some, evidence of this specimen's use, the why behind the specimen, and one of my favorite parts is that it was sent by J.H. Christ, who we all know was the chief agronomist in the Colorado Department of Agriculture, right? Yeah. So, yeah. So I like to leave, this specimen story and kind of the conclusion of this today with just thinking about for the future, for all collections that we all make, to really document a little bit more about the why as part of our extended specimen concept. And with that, I want to thank you. Yeah.
All right, well, that concludes our session today. Thank you very much for everyone, all the speakers in the audience. Remember to go back to your collections and think of a next one for next year. And also, I have an announcement I'm supposed to read. T-shirts need to be picked up during lunch. Both existing orders and those who ordered them yesterday or this morning on site should go up and pick up their T-shirts. So before you get lunch, grab your T-shirts.